Hello students, welcome. Today in this video lecture we are going to study flame emission spectroscopy, its instrumentation, construction and working, and various components of flame emission spectrophotometer. So let's start with instrumentation of single beam flame photometer. We know that for excitation of elements, high flame temperature is necessary. The following diagram shows the various parts of flame photometer. Okay, it is the block diagram of flame emission spectrophotometer. Okay, flame emission photometer. Sorry, here is the flame. Okay, fuel and oxidant and plus sample. Okay, these three things are provided to the flame. Then it is connected to the monochromator. After that, next component is the detector, amplifier and readout device. Okay, these are the components present in flame photometer. Okay, this diagram can be also drawn as below. Here is the flame. Okay, in flame, fuel, oxidant and sample solution are passed and mixed at the tip of flame. Okay, then the species which are present in sample solution are get evaporated, and there is a dissociation takes place. After that, there is a formation of atoms. Okay, and some of the atoms are get excited and emit some light radiations. Then these radiations are fall on the surface of monochromator. After that, that signal is fall on the surface of detector. Here is a photomultiplier tube is used as a detector. Then that signal is get amplified and recorded by readout device. Okay, it is a diagram which shows flame photometer, various parts of flame photometer. Okay, next one is the choice of gases. We know that in this diagram there is a need of, okay, for the flame there is a need of fuel, oxidant. Okay, so which type of fuel and oxidant pair is used for flame is decided by the nature of component which is present in the sample. So next point is the choice of gases. Various flames can be used in flame photometry. For example, air methane, air illuminating gas, air propane, oxygen propane, air gasoline, air acetylene. Okay, it is a pair of what? Oxidant and fuel. Okay, generally oxidants are air or oxygen gas and fuels are methane, illuminating gas, propane, gasoline, air acetylene. Okay, generally this fuel oxidant pair is used. The choice will depend on the type of element to be determined. The flame temperature. We know that flame temperature must be high. The temperature of the flame depends on the type of gas mixture and on the mixing ratio of the components. Which type of gas mixture is used? Okay, on that the flame temperature is depend. Okay, and also it is depends upon the mixing ratio of the components, that is fuel plus oxidant mixing ratio. On that mixing ratio, flame temperature is depend. The excitation of a spectral line depends on the temperature. We know that for the excitation, the high temperature is required. And we know that this relationship between the number of excited atom and temperature is shown by Boltzmann equation. A hotter flame better vaporize the sample. So, flame temperature must be high enough to vaporize the sample. Higher temperature promotes dissociation. of non-emitting compounds like alkali halides or alkali hydroxide. So higher temperature must be required for excitation. Then gas regulation. Gas regulation means what? The control of flow rate of fuel and oxidant. Why it is necessary? For quantitative flame photometry, a reproducible and steady flame is required. Okay? For quantitative measurement, reproducible and steady flame is required in advance. So, flow of fuel gas and oxygen or air to the flame must be kept as uniform as possible. Okay. Flow rates of the fuel and oxidant. For a given sample and instrument, both intensity and the steadiness received by the detector depends upon flow rate of the fuel and oxidant. Okay, the intensity and steadiness of emitted radiation received by the detector depends upon what? Flow rates of fuel and oxidant. So next point is the introduction of sample into the flame. The uniform feeding of the sample or standard into the region of excitation is very important for accuracy of procedure. So it is very important to feed the sample in uniform rate. For flame analysis, the substances is generally dissolved in acid, okay, and then they sprayed with an atomizer. Firstly, the substance is dissolved in acid, then that solution is sprayed with an atomizer. So the sample solution goes into the flame in the form of mist. Okay. Then the aerosol of liquid droplets in air or oxygen is then mixed with gas. These droplets are then mixed with fuel and oxidant into the flame. The next point is the burners. Burners. Generally, there are 4 types of burners used in flame photometry. Okay, we will see this one by one. The mixture of mist, that is droplets, fine droplets of sample solution, mist, air or oxygen and the fuel gas is conveyed to the burner, above which the flame burns. Okay, these three, mist, okay, that is mixture of mist, that is sample, then air or oxygen and fuel, these three are conveyed to a burner and above which the flame burns. There are also atomizer burner combinations in which the liquid is atomized and the oxygen and gas are mixed at the actual tip of the burner. Some of the burners used are Beaker burner, open burner, okay, then total consumption burner and premix burner. Okay, these are the 4 burners which are used generally in flame photometry. Out of this, the open burner or Bunsen burner, which is used in laboratories. Okay, these are hardly used since the flame easily flashes back. Okay, and the Meeker burner, it is commonly used in flame photometer. Some of the advantages of Meeker burner are: the burner cap can be cooled easily, the temperature of the flame is more uniform, the flame is steadier, the possibility of flashing back of the flame is very rare. These are the advantages of Meeker burner. So, if there are open burner and Meeker burner are available, out of these two, generally Meeker burner is preferred. Why? Because the burner cap can be cooled easily, temperature of the flame is more uniform, the flame is steadier, and there is a possibility of flashing back is very rare. And there is a one disadvantage of Meeker burner, that is producing relatively low flame. Okay, it produces low flame. So only alkali metals can be determined quantitatively by using Meeker burner. It is not useful for alkaline earth metals. So it is a disadvantage of Meeker burner. Only alkali metals can be studied because flame temperature is very low. Then next, third type of burner is a total consumption burner. Okay, total consumption, that means the sample solution which is used for analysis is completely passed into the flame. There is no wastage of samples, so it is called as total consumption burner. Look at the diagram. It is a total consumption burner. Okay, in that burner, sample, fuel and oxidant are passed in different way, and they get mixed at the tip of the burner where flame is present. Okay, the name total consumption burner is given because all the sample which enters the capillary tube will enter the flame, neglecting the size of droplet. Okay, all the sample which enters the capillary tube will enter the flame. Okay, neglecting the size of droplet. Then it consists of a straight capillary tube. Okay, here it consists of straight capillary tube over the lower part. It is concentrically surrounded by oxygen nozzle. Okay, here it is the oxygen nozzle. Okay, the capillary tube is concentrically surrounded by oxygen nozzle with a capillary tapering tube. Okay, capillary with a conically tapering tip. Okay, then the oxygen stream produces suction and atomizes the sample. This oxygen stream produces a suction and atomizes the sample which is coming out through the capillary. Okay, then that oxygen nozzle is again concentrically surrounded by a nozzle for the gas. Okay, or fuel. Thus, the mixing of gases and atomization occur above the tip of the nozzle. Okay, mixing of the fuel, oxidant and sample solution is takes place at the tip of the nozzle. It is the total consumption burner. The advantages of this burner is atomization efficiency is 100%. Okay, no flashback of the flame. Combustible substances like gasoline can be safely spread by using this burner. The disadvantages are what? Noisy and turbulent. Okay, that burner is noisy and turbulent. Losses due to incomplete evaporation of the larger drops in the flame is observed. Okay, because from the capillary, not uniform size droplets are passed into the flame. Okay, different size droplets are passed. So there is a loss due to the incomplete evaporation of the larger drops in the flame is observed. It is a disadvantage of total consumption burner. Then misalignment of atomizer makes the flame lopsided. Okay, there is a not uniform flame is observed. Lopsided means it is hanging to the one side. So these are the disadvantages of total consumption burner. The next point is the premix or laminar flow burner. Okay, there is a fourth type of burner. The name shows what? Premix. In total consumption burner, the fuel, oxidant and sample all are mixed at the tip. But in this case, the fuel, oxidant and sample are get premixed and after that they reach the flame. So this burner is called as premix or laminar flow burner. The most important advantage of this type of burner is that aspirated sample, fuel and oxidant are premixed before they reach the opening of the burner. Here they are get mixed before reaching the burner, opening of the burner. Okay, after throughout mixing they enter the flame. The gases move in non-turbulent way. Okay, we have already seen the disadvantages of total consumption burner. Disadvantage is what? It is a noisy and turbulent. But premix burner, here the oxidant, fuel and solution are get premixed, and after that they reach the flame. So these gases move in non-turbulent way. It is the advantage of premix burner. The important disadvantage of this burner is that very small part, that is nearly about only 5% of the sample reaches the flame. Okay, so in other words, the sample are wasted. Hence, this burner a pure or low sensitivity. Okay, only 5% sample reaches the flame. So most of the sample get wasted. So it has poor sensitivity, and we have already seen the advantages of total consumption burn. It has 100% efficiency. Okay, but in case of premix burner, only 5% sample reaches the flame, so it is poor or low sensitive. So these are the 4 burners which are used in flame photometer. Okay, and advantages of these burners are what? This burner is noiseless, non-turbulent and stable. It is noiseless, non-turbulent and stable. Decomposition of the sample in the burner takes place very easily, and hence efficiency of atomization is very great. The obstruction of the sample solution is negligible. These are the advantages of premix laminar flow burner. Okay. Then next point is the series of events in a flame. Here we see the steps involved. The steps which are takes place in a flame. We have already seen it in diagram. Okay, again we will see these steps. First step is what? Formation of minute particle of the dry salt on account of evaporation. Then after evaporation, there is a conversion of dry salt into gaseous state due to vaporization. Okay, and after that, formation of free neutral atoms or radicals because of dissociation of gaseous molecule. Okay, first step is what? Formation of minute particles. Then there is a conversion of dry salt into the gaseous state. Firstly, there is a evaporation takes place, that means solution is converted into solid dry particles. Then these dry particles again they are converted into gaseous state due to vaporization. Okay, and after vaporization there is a dissociation of gaseous molecules takes place, and there is a formation of free neutral atoms or radicals. Then after that, ionization of neutral atom takes place and formation of new gaseous compounds due to the combination of neutral atoms or radicals also takes place. So these are the series of events which are takes place in flame. The next component is the mirror. What is the role of mirror in flame photometer? Okay, a small portion of radiation emitted by the flame enters the flame photometer. Okay, only small portion which is emitted by the flame enters the flame photometer. So in such case, a gain in sensitivity can be achieved by increase the light intensity by placing a mirror behind the flame. Okay, here mirror is used for what? To increase the sensitivity of emitted light radiations. Okay, these mirrors are placed behind the flame. Generally, concave mirrors are used. Okay, then what is the function of this mirror? The concave mirror creates an inverted image of the flame. Okay, it creates what? Inverted image of the flame of equal size at the location of the flame. This might be expected to double the light intensity, but due to self-absorption, the gain is less. But there is some increase in the sensitivity. Next component is the slit. There are two types of slit, entrance slit and exit slit. Okay, in the operation of the monochromator, the entrance and exit slit must be adjusted properly. The position of entrance slit, okay, it is placed between what? Entrance slit, it is placed between the flame and detector. The main function of the slit is to allow only radiation from the flame and a reflection of the flame from the mirror. Only the radiation which is coming out from flame and the reflection which is coming out from the mirror is allowed to pass through the slit. Similarly, the position of the exit slit is between monochromator and the detector. Also, its function is what? To allow only selected wavelength from the monochromator. Only selected wavelength from the monochromator to the detector. So, the interfering lines are also prevented, that is, they are cut off. It is the function of entrance slit and exit slit. The next component is the monochromator. The term monochromator, the name shows what? It gives monochromatic light. Okay, the name applied to the combination of all the components from the entrance slit to the exit slit. It is a combination of component, entrance slit, okay, then some dispersive medium like prism or grating is used, and after that exit slit is there. So it is a combination of components from entrance slit to the exit slit. The purpose of the monochromator is to supply the sample with light of only one wavelength. Okay, it is also called as monochromatic light. Monochromator gives what? Monochromatic light. Two types of monochromator are used, prism or grating monochromators. For greater accuracy, gratings are used. Out of these two, okay, grating is used for greater accuracy. But when grating is used, the cost of instrument increases because it is very expensive. And next, filters. When filter is used as a monochromator, the cost of the instrument is very low. And generally filters are used for simple analysis. Okay, monochromator gives monochromatic light, but filters are gives what? They give a very narrow beam of wavelength. They do not give us light of single wavelength. So when simple analysis are to be carried out, at the time filters are used. The next component is the detector. Okay, detectors. The photodetector should be so placed that the beam of light emerging from the optical system covers the entire photosensitive area. Okay, it is the condition for placing the detector. It is placed in such a way that the light which is coming out from the optical system, that is from monochromator, which covers the entire photosensitive area of the detector. If the detector is too close to the exit slit, only a small region of photosensitive area will be utilized. Or if it is placed too far away from the slit, then some of the light will pass the photosensitive surface unused. Okay, so the position of detector is very important in this method. It is placed in such a way that what? The light emerging from the optical system covers the entire photosensitive area. It is not too close or not too far from the optical system. So, in a good instrument, the photodetector has usually been correctly adjusted. It must be correctly adjusted. Okay, the next component is the amplifier. In many cases, the photocurrent from the photocell or photomultiplier tube goes directly to a sensitive indicating meter, that is readout device, to provide a reading. But if the sensitivity of the optical electric system is insufficient, the current or voltage can be increased by introducing an amplifier between the detector and meter. Okay, if sensitivity is less, okay, then the current or voltage can be increased by using amplifier. Generally, this amplifier is placed in between detector and meter, and then that amplified signal is fed to the readout device. So, a good amplifier must have constant sensitivity, good linearity, and long-lived tube, etc. Okay.